My dear students, today I am going to discuss about the practical classes of soil science. It's a mandatory for the RAWE students. So as I have been assigned by the Dean Agriculture that you have to give some brief idea about the practicals of soil science. So the RAWE students, I would like to say, as you know that there are so many things which is required to be studied in the laboratory. Say for example, for physical property, you have to analyze the soil texture. Then you have to analyze also about the bulk density. These two are more major parameters which you have to study. So soil texture and bulk density. So regarding this, I am not going to discuss you today. I will discuss you later on. The most important parameter is the chemical property of the soil. Chemical property of the soil. So in this paragraph, I will discuss about the pH, organic carbon, available nitrogen, available phosphorus, available potash, and other some essential micronutrients. Let's say for example, zinc, copper, manganese, iron, and so on. So, my dear students, in case of pH, you know the pH of the soil is much more important to know the nature of the soil. So for pH, nothing you have to do, only you take 20 gram soil and add. If you are taking 20 gram soils, you add. The ratio of the soil and water will be 1:2.5. So, if you have taken 20 gram of soil, you add 50 cc distilled water. Shake it half an hour. This 20 gram soil you have to take in the beaker, in a plastic beaker or in a plastic beaker, and add 50 cc distilled water, stir it half an hour, and take the reading with the help of pH meter. In this, before taking the reading from the pH meter, you have to do one thing. Switch on the pH meter and adjust the knob to stabilize the temperature, room temperature, to know the room temperature. Generally, pH varied with the variation of the temperature. It will vary. In the winter season, if you take the reading, the pH value will be something different of the same soil, and the summer season the pH value of the same soil will be different. So temperature is a major things. You have to make it constant, that is 25 degrees centigrade. So we have to maintain this temperature. Now come. Before taking the reading with the help of pH meter, you have to calibrate the pH with the buffer solution. The buffer solutions will be of 4, 7 and 9.2 pH buffer. Okay. Now, so first of all, whenever we switch on the pH meter, we calibrate the pH meter with the help of 7, then followed by 4, then followed by 9.2 pH. So after calibration of the pH meter, you take the reading of your soil samples. So this is whatever the reading will come, that will be the direct reading of the pH. So this is the methods of pH, determination of pH of a soil. Now, you know, generally pH of the soil varied from 3.5, you can say 3 to 6.5. This is called acid range. 3 to 6.5 pH is the acid range. And if the pH value is 6.5 to 7.5, then it is called neutral pH, neutral pH. So the most desirable pH for a soil scientist, for a farmers, is the 6.5 to 7.5 pH. Now, and above them 7.5 pH comes under the alkaline range. Organic carbon content, determinations of organic carbon of a given soil sample. Organic carbon of a given soil sample. What you have to do? This organic carbon, determination of organic carbon, it was given by this methodology was given by the Walkley and Black. Walkley and Black in the year 1934. Okay. This organic carbon, this methodology is also known as determination of oxidizable organic carbon. Okay. Now what we have to do? To take 1 gram soil in a 500 ml conical flask. In a 500 ml conical flask. Then add 10 ml 1 normal potassium dicarbonate, ml 1 normal potassium dicarbonate K2Cr27, then add 20 cc 20 ml concentrated H2SO4. Left it for half an hour, left it for half an hour to complete the oxidizations. This potassium dichromate is the oxidizing agent. It will act as an oxidizer, and this sulfuric acid will accelerate the oxidizing process, because whenever you add this sulfuric acid, it will generate the heat, and due to the heat, the reactions will be more fast. Now, after half an hour, you add 150 ml or 100 ml distilled water. And if you don't have distilled water, you can add the tap water also, nothing to worry. Then after addition of this 150 ml distilled water, you add 10 ml orthophosphoric acid, H3PO4. Orthophosphoric acid. After addition of orthophosphoric acids, you add few drops, 1 ml, few drops of diphenylamine indicator. Diphenylamine indicator. Everything will be added in that conical flask, in that 500 ml conical flask. Now, side by side, you prepare the blank. BLAN, you prepare the blank. In blank, the soil will not be there, and all the reagents will be there. So, now you have to titrate. You have to titrate these things with the help of 0.5 in ferrous ammonium sulfate. 0.5 and ferrous ammonium sulfate. You have to titrate it. Then, after titration, the in point will become, take the reading of this in point and note it down in your notebook. Note down in your notebook. So first of all, if you have to go for this titration, you do the titration of your blank sample. First of all, you have to titrate your blank samples. So in blank sample, after titration, you may get some value. Titrated value you will get. Let's suppose the value is the B. So this is the titrated value. This B is the titrated value. And whenever we have titrated the soil samples, and you have got this titrated value of the soil is the, let's suppose is the T. So what will be the calculation? Now we have to calculate the organic carbon content of the soil. So what we will do? What will we do? Just see. 1 liter, or you can say 1000 ml, 1 normal potassium dichromate K2Cr2O7 equivalent to 3 gram of carbon. Equivalent. 1 normal N potassium dichromate is the equivalent to the 3 gram of carbon, because you know the molecular weight of the carbon is the 12 and the equivalent is the 3. 12 divided by 4 is equal to 3 gram of carbon. So 1000 ml of 1 potassium dichromate equivalent to the carbon of carbon. Now if it is 1 ml of 1 normal K2Cr2O7 equivalent to 0.003 gram of carbon. Okay. Now for calculation what you have to do? Organic carbon is equal to 10 into B minus T. What is T? 10. You have taken the 10 ml of potassium dichromate. So that's why this 10 is here. B is the blank value of the titration without soil value of the titration. This is the B, and this T is the titrated value divided by blank B into weight of the soil into 100 into 0.003. Okay. So this is the calculations of the organic carbon content of the soil. This organic carbon content, through this method, this Wakeland Black methods, this organic carbon content will come this much amount. So this organic carbon is called, this is also known as oxidizable carbon. This is also called as oxidizable carbon. Now, so I think we have written all 10 within bracket B minus T divided by B into W into 100 is the percent and 0.003. It has been assumed, not assumed, it has been observed with the help of these methods, this Wakeland Black methods, only 77% carbon will be recovered from the soils. Only 77%. So what will be the factor? What will the factor? 100 divided by 77 is equal to 1.3. So the total organic carbon is equal to the value, whatever the value you have got, that is 10 within bracket B minus T divided by B into W into 100 into 0.003 into 1.3. So this is total organic carbon content of your soil samples. Okay? Or you can say, or Y into 1.3%. 1.3 is the factor. Now come. Second, now you have to determine the organic matter. From the same soil samples, you have to determine the organic matter. So, through this Wakeland-Black methods, it has been assumed that only 58% will be recovered from the total organic carbon. So 58%, it means 100 divided by 58 is equal to 1.74. So whatever the value we will get of the total organic carbon content, the value will be multiplied by 1.74. Total organic carbon content, total organic carbon content multiplied by 1.74 is called total organic matter content of the soil. So this is all about the organic carbon determination process of the soil samples. So my dear students, if you have any confusion, you may ask to me. Anytime you can ask to me regarding the determination process of this organic carbon content of the soil samples. Now, one thing I have missed. So during the pH determination, we have to also study about the electrical conductivity. Why it is required to know the electrical conductivity of the soil? Because you know, most of the cations and anions are present in the soils. Mainly the cations, calcium, magnesium, potassium, potassium. These are the most common cations which is found in the soil. And the most important anions, these are the cations, and what are the anions which is most commonly present in the soil? That is the sulfate, carbonate, chloride, and bicarbonate. These are the most common anions which is present in the soil. So, for knowing the electrical conductivity, means to know the total ions content of the soil. If the quantity of the ions, either cations or anions, will be more, then it will increase the more osmotic pressures. And due to the more osmotic pressures, the plants exert more energy to extract the water sample or water, to extract the water or plant nutrients. So that's why the determination of electrical conductivity is required. Determination of electrical conductivity is required only due to to know the ions concentration of the soil. If the ion concentration of the soil will be high, then the plant faces a lot of problems in absorptions of water, in absorptions of nutrients. So, electrical conductivity determination is more required. Now come, although in Ranchi, Jharkhand, this EC is not so much common problems, but in these problems is occurred in the arid regions, majority of the arid regions, then it creates more problem in the salt affected soils. So this is EC. In EC, nothing you have to do. You take the soil samples. You take the 20 gram soil samples, add 50 cc distilled water, stir it and take the reading with the help of electrical conductivity meters, EC meters. Now come. Another most important nutrients for the growth of soil plants, is the nitrogen. We know that this majority of the nitrogen is present in the soil in a form of organic combinations. The majority of the nitrogen is present in the organic combinations. So, now you have to find out the nitrogen content of the soil. What is the amount is present in the soil samples. So for knowing the amount of the nitrogen in the soil, one scientist, Subba and Asija, in the year 1956 given a methods that is known as Gel-Dahl methods. Gel-Dahl. methods. So with the help of this Gel-Dahl methods, you can determine the nitrogen content of the soil. So what you have to do? you take 20 gram soil in a geldal flask, geldal flask, in a geldal flask. Then add 0.32% potassium permanganate KMnO4. Hundred ml. Okay. Then add 2.5% sodium hydroxide solution, 100 ml. So sorry that this 0.32% potassium KMnO4 potassium permanganate is the will be 40 ml only. This will be only 40 ml, not 100 ml. This sodium hydroxide will be 100 ml. Add it, and side by side, take a conical flask, and in a conical flask, you take 20 cc, 2% boric acids, boric acid, that is 20 cc in a conical flask, and this conical flask will be adjusted in the gas liberation point. And this conical flask is called a receiver. It will receive the gases. Whatever the gas will come out, it will be absorbed in this 2% of boric acids. Okay? Whenever the gas will come, this boric acids will become pink. It will become so 2% boric acids. So this is the whole methodology of the geldal flask. After completion of distillations, you remove this conical flask and titrate this conical flask, this receiver. This conical flask is called receiver. In that conical flask, 2% boric acid, 20 cc will be there. After completion of distillation, you have to titrate 0.02 N sulfuric acid, H2SO4. Okay. you have to titrate it through 0.02 N sulfuric acids. In the same way, in the same manner, you have to also prepare a sample without soil. Here soil is there, but in another sample the soil will not be there. That is called blank. That will be called blank. So you have to prepare this blank also. Without soil, you have to add this all sort of things, and you have to titrate this blank also with the help of this 0.02 N sulfuric acids. One thing I forget, I could not say you, but now I'm telling you. During this preparation of this receiver, in that conical flask, the 2% boric acids will be there. So in that 2% boric acid, you have to add few drops of mixed indicator. Few drop of mixed indicator. Mixed indicator. It will be available in the laboratory. So, but I will tell you that how to prepare this mixed indicator. So, whenever you prepare this receiver, 2% boric acids of 20 cc in a conical flask, you add few drops of this mixed indicator. Okay. Now, then after that, then you have to add this. You have to titrate this with the help of this 0.02 and H2SO4. Now, these methods of determinations of nitrogen, it will give you the value of two types of nitrogen, that is ammonical nitrogen and nitrate nitrogen. Both form of the nitrogen will be there, and altogether it is called as mineralizable nitrogen. Mineralizable nitrogen. It is called mineralizable nitrogen. So, now come to the point, how to calculate the value, how to calculate the nitrogen of a soil sample, calculations. What is the nitrogen? Is the 14 gram. Now come. Thousand ml, or you can say 1 liter of sulfuric acid H2SO4 equivalent to 14 gram of nitrogen. Equivalent of 14 gram of 14 equivalent to 14 gram of nitrogen. 1000 ml. Now 1 ml of H2SO4 is equivalent to 14 milligram of nitrogen. Is it not so? 1 ml of H2SO4 equivalent to the 14 milligram of nitrogen. Now second step is the 1 ml of 0.02 N H2SO4 equivalent to 14 into 0.02 milligram of nitrogen. Milligram of nitrogen. Okay. One ml of it. So you can say like this: the titrated value the titrated value means blank the value of blank titration minus value of soil titration is called titrated value. Equivalent to will be equivalent to now just see titrated value blank minus T ml of 0.02 N H2SO4 equivalent to B minus T into 0.02 into 14 milligram of nitrogen. It's a simple calculations, nothing to worry. So in this way, if you calculate the everything, it will come. And what was the amount of your soil samples? That was 20 grams. So 20 gram of soil contains this much amount, B minus T, this is titrated value, into 0.02 into 14 milligram of nitrogen. So if you have to calculate the 1 hectare land, so for 1 hectare land, so it will come 30.8 into titrated value B minus T. This is called titrated value. So it kg per hectare. So remember this factor, this 30.8. So how it has come? It has come from the previous this 30.8, it has come from the previous one. This calculated value will come, this B, let's suppose B is the 20.5 ml and T is the 17.3 ml. So if you deduct, it will come 3.2. So 3.2, so simply you have to put the value here 3.2 multiplied by 30.8. Whatever the value will come, it will be this much kg of nitrogen present in the soil, and the value will come in the kg per hectare. Okay, so this is all about the nitrogen, determinations of nitrogen and organic carbon content of the soil and pH of the soil and EC of the soil, electrical conductivity of the soils. Now, one is the fertility chart. Fertility chart, or you can say, is how you can say that our soil is fertile or non-fertile. So there is even some chart, some value is given by some of the scientists. So organic carbon. This is organic carbon. If the value of organic carbon is less than 0.5, it means your soil is low. Your soil is low. And if the value of organic carbon is 0.5 to 0.75, then the soil will comes under this medium class, in medium. And similarly, if the value of the organic carbon is more than 0.75, then high. The status of organic carbon is high. This is the chart. Now, in the same manner, in the same way, nitrogen status. Nitrogen. If the value of the nitrogen of your soil is less than 280 kg nitrogen per hectare, it means that there is a deficiency of your nitrogen in the soil. If the value of your soil samples will come in between 280 to 560 kg per hectare, then your soil will be medium in nature, medium. This is low, this is medium. And the same manner, if the more than 560 kg per hectare of nitrogen, then it is high. Okay, so in this case, whenever you will get the more value of nitrogen, so you don't have to bother for this applications of nitrogen. So you have to consider only this 280 kg or 280 in 560 kg. So, my dear students, this is all about the nitrogen organic carbon content of the soil, and this organic carbon and nitrogen is more basic requirement for the soil fertility. For if any soil having more amount of organic matter, organic carbon, more amount of nitrogen, it means your soil is very fertile. need not to bury. You should, as you know, soil is the very complex. Soil is the very complex. Very complex. If the pH is acidic in nature, then you have to go for this lime application. And generally Jharkhand pH is less than is acidic in nature, so lime is recommended to the farmers, and it is recommended 3 to 4 quintal per hectare in furrow. In furrow, it is recommended 3 to 4 quintal in furrow. And if you have to apply, then not in furrow, if broadcasting, in a broadcasting way, then you go for this in ton, 4 to 5 ton per hectare. This is broadcasting. Okay. Now, determinations of potassium, determinations of K. Determination of K in a soil sample, of a soil sample. What you have to take? To take 5 gram soil in a conical flask, add 25 cc 1 normal ammonium acetate, 1 normal ammonium acetate, 1 normal ammonium acetate neutral. The pH should be 7.2. Shake it half an hour and take the reading with the help of flame photometer. Flame photometer. Before taking the reading of your soil solutions, of your soil samples, you have to sterilize this flame photometer. You have to calibrate this flame photometer with the help of standard solutions. Standard solutions means known strength solution, that is called a standard solution. So, before taking the reading of your soil samples, you have to sterilize this flame photometer with the help of a standard solution. A standard solution, what is a standard solution? It is known strength solution, which is well known to you. That is called standard solutions. Now question arises, how do you prepare these standard solutions in a laboratory? So you have, I think you have this 5 gram soil sample. You take this 5 gram soil samples in a conical flask, add 25 cc, 1 normal neutral ammonium acetate. Shake it half an hour and filter it. Shake it half an hour and filter it, and then take the reading of the filtered. Before taking the reading, you have to calibrate your flame photometer with the help of standard solutions. Okay? Now come how do you prepare the standard solution? Let's suppose you have to prepare the standard solutions of potassium. You have to prepare the standard solution of potassium. So you take potassium chloride, okay, calculate the molecular weight of potassium chloride, calculate the molecular weight of the potassium chloride. Let's suppose the molecular weight of the potassium chloride is X gram. So out of this X gram, how much potassium is there? Let's suppose Y gram K is present, Y gram K is present, X gram KCl. Y gram K is present in X gram KCl. Now, 1 gram K is equivalent to X divided by Y gram of KCl. Okay? Okay? This XY gram of KCl, suppose it is Z gram of KCl. Suppose it is Z gram of KCl. So take this Z gram of KCl, take Z gram of KCl, dissolved in 1 liter distilled water. 1 liter distilled water. Okay? Take Z gram of KCl in 1 liter, this is ml, 1 liter distilled water, and the strength of the solutions will be 1000 ppm. Okay? It means this Z gram of KCl. Z gram of KCl means 1 gram potassium. So 1 gram potassium dissolved in 1000 ml distilled water gives you the 1000 ppm of a standard solution. 1000 ppm of a standard solutions. From this 1000 ppm of a standard solution, now this 1000 ppm standard solution is called, you may call it is a stock solution. A stock solution means you can keep it for longer period, and whenever you require, you dilute it and prepare your solutions for calibration of the instruments. So this is 1000 ppm. From this 1000 ppm, you have to prepare the different strength of the solutions. This 1000 ppm ppm of K solution is you have already prepared 1000 ppm of K solution, potassium solutions. Now you have to prepare from this solution working solution. Working solution means the lower strength solution. Working solution. That is lower strength solution is there. You have to prepare 10 ppm, 20 ppm, 100 ppm, likewise. So whenever you will come in the practicals, you will do this work manually, then you can understand what the strength is required for you. So for potassium, up to this 100 ppm is required. So for this preparation, what you have to do? You know the S1 into V1 is equal to S2 into V2. You have to prepare this 10. Okay? So now put the 10 here and you just assume what quantity is required. If you have to require 100, prepare 100 ml, you prepare 100 ml. If you require 25 cc, you prepare 25 ml. So let's suppose you require only 25. So you put it here 25. This V2 you have to prepare. This S2 you know you have to prepare this 10 ppm. Now here S1 is known to you. S1 is the 1000 ppm and V1 you have to calculate the V1. So V1 is equal to 10 into 25 into divided by 1000. So whatever the value will come, you extract, you pipette the amount, the volume, the amount, and make it volume and make its volume 25 cc, and make it volume, make the volume 25 cc. So where you will make the volume? In a volumetric, remember it, in a volumetric flask you have to make this volume of 25 cc. Take this XML from this 1000 ppm stock solutions and this then again dissolve it. Dissolve it means you have to make the volume 25 cc with the help of distilled water. So this is the way to preparation of the standard solutions. Okay. So this way you can prepare the standard solution of 10 ppm, 20 ppm, 1000 ppm. And not 1000 ppm, sorry, 100 ppm. So these lower concentration volume, lower concentrations of any solutions is called working solutions. And before taking the reading of your soil samples, you have to calibrate your instruments with the help of lower concentrated volume of the lower concentration volume of the potassium or sulfur or phosphorus, whatever the nutrient is, you have to go for the study. After calibration, you run your samples and take the reading of the flame photometer. So before taking reading, one thing always remember, you have to run your standard solution, and then after calibration of the instruments, you have to go for the unknown solution. Unknown solution means your soil samples solutions. Now come. calculations of potassium. K you have taken. This is very simple calculation is there. You have taken 5 gram soil sample and you have added 25 cc, 1 normal ammonium acetate, 1 normal ammonium acetate. So dilution factor is dilution factor is so dilution factor is 5 times. 5 times. So whatever the reading will come in your flame photometer, that reading will be multiplied by this dilution factor. So K content of your soil is equal to reading multiplied by dilution factor, that is 5. This 5 is the dilution factor. So that will come in under, that will be the ppm. Okay, that will be the ppm. And now you have to convert this value in your kg per hectare. So in kg per hectare, what you will do? For knowing the potassium status of your soil, so whatever the reading will come, it will be simply multiplied by the dilution factor, and that will become an ppm. ppm means milligram per kg. ppm is also called known as milligram per kg. Okay, milligram per kg. Now we have to do kg per hectare. So for kg conversion in kg per hectare, what you have to do? Reading into dilution factor, into 2.24. That will be kg per hectare. Okay? Because 1 hectare land contains 2.24 into 10 to power 6 kg. Okay? So this is the way. So this way you can calculate the all things. So my dear friends, this is all about today. On next classes I will tell you something more. So today whatever you have discussed, pH, organic carbon, electrical conductivity, or nitrogen and potash. Okay? So thank you very much. Whenever you face any trouble, you can call to me, you can ask to me any questions, any type of problems related with the soils, particles. Okay? Thank you very much. Thank you very much.